Yeah, hi. I was thinking about earthquakes and Parkland currents and stuff recently. For some reason, never thought I would think about these kind of things, but obviously I do. Science news for students explain the Earth layer by layer. Sizzling heat, unimaginable pressure, and some surprise diamonds. It's all deep there beneath us. Mm, Still, scientists know a great deal about Earth's inner structure. They've plumbed it by studying how earthquake waves travel through the planet. The speed and behavior of these waves change as they encounter layers of different densities. Scientists, including Isaac Newton 3 centuries ago, have also learned about the core and mantle from calculations of Earth's total density, gravitational pull, and magnetic field. This is the picture. Crust 0 to 100 kilometers thick. Okay, this is the first part of the hole. Let's go on. Let's go a bit deep in the rabbit hole. Which isn't probably that much of a rabbit hole after all. Let's have a listen to Wal Thornhill. He has quite much to say.
So I was very interested to come across this book, A Hollow Planet by Jan Lamprecht, a South African computer IT expert. And he looked at the historical ideas about hollow planets, and most of them referred to a hole at the poles. Well, forget that. But there are all sorts of fanciful theories about what was inside the Earth. And of course, all models of the Earth's interior assumes Newton's law applies right to the centre of mass, but the centre of mass is a physical nonsense. And Jan Lamprecht made the point that deep earthquakes down to 600 kilometres and below occur, where the Earth's mantle should be like treacle and not subject to shearing, because the earthquake is supposed to be rocks moving past one another, shearing, breaking. And he had some very good arguments why the Earth should be hollow. And one of them was that the shadow region in the opposite hemisphere to a powerful earthquake, you have a powerful earthquake here, and you get signals which are curved up this way. So you get echoes all around here. And then you have a blank spot, and then they appear over here. And this has required all sorts of fanciful objects inside to try and explain how on earth you get a signal through the so-called liquid core. So you have an outer core and an inner core and all of this kind of thing. The simplest answer, if you get rid of the inner and outer cores, is that you have a shell. And the density increases as you go down, and then it gets to a point where it decreases again. So there's some area here, some point at some depth, where the density begins to reduce once more. And when you do that, this shadow region over here is very easily explained. It falls out as a natural consequence. But the other aspect of all this is that we are unable to determine the amount of matter in a celestial body by measuring its gravity, because it makes all of the Newtonian assumptions which are incorrect. The calculated densities are meaningless.
So, now I created a picture. At least two, that's the first one of those. It is not to scale. I tried somehow to achieve some kind of scale, but it's not easy since I can't measure. This is Earth's diameter, more than 12,000 kilometers. The deepest quake is measured 987 kilometers. And if you take a look at that, there is still 5,877.5 kilometers left to the center of that. And for comparison, here is somehow our atmosphere. You can actually see it somehow, which is about 500 kilometers. It's not that big. And of course, we have magnetosphere layers. This should be actually a little bit more far out, but it didn't fit. And on this side, this is how Thornhill explains the repellent core, or how to put it. Since the slight distortion of the gravitational force pulls all those in the center, there will be on this side the same polarity as on these. Anyway, for comparison, there is a geoid. A geoid here, and it is hollow. And this one in the middle came across today or yesterday at App 2030, found somewhere this plasma lab discharge pictures, and I thought this fits really well to what I was trying to do, because I didn't find any better picture. And this one is also here, so it's not that deep. We don't get really far with that. 3,000 kilometers. There's still plenty of space left. So these are like the blue one could be the South Pole, the red one is the North Pole. And I was really creative. You can see here's a geoid embedded into the picture. And that structure here is the picture I took from La Palma, from the tornado, with the ring around it. So I just somehow thought if there would be space in the middle of Earth, if there wouldn't be a liquid core, as they say, and there would be this kind of plasmoid thing there in the middle, and the layers, like the innermost layers, there would be this kind of really crystallized, whatever, diamonds or what have you, something which really makes it possible for energies to flow from the inside to the outside, as the arrows show. And this ring here would be the equator. And where we have those, like I have another, here's a maybe better picture. Like if you would imagine, like it would look like this Earth. Here we have a volcano. Here would be nothing probably. Here would be a lava chamber. Volcano. Sometimes it's thicker, like here, and then it gets really thin, like here. And you have different kinds of layers, like you have in petrified wood. And since electric currents are spinning, Bertrand currents are spinning, Earth spins too. And there would be the explanation for the immense heat which comes from underground. if there would be this kind of plasmoid thing there in the middle of Earth, which extracts heat, melting rock, and these kind of things. And I was thinking about like Schumann resonance. If you have a resonant body which is resonating, it might be hollow, like a violin or a guitar. There is the resonate body. So if the Schumann resonance changes, or would change, like in a bigger scale, would this mean that either the crust gets thicker or thinner by accretion from above or from below? I don't know. Something I was about to say still. I forgot it. I don't remember. Yeah, actually. The plasmoid thing, theory, or whatever this is. This would also explain the really quick and strong reaction to electromagnetic changes from Earth's environment, let it be by the sun or comets or what have you. I will leave it here. This is somehow one thing I was thinking about recently, and somehow to me it would make sense. It would explain why there is heat coming from underneath. It doesn't have to be molten, probably there's just some few thousand cubic kilometers of space where is super ionized gases, whatever matter we have there. Some kind of a stationary sea pinch. And we have sea pinches on Earth's surface. Let me show one. Here is Europe's sea pinch. This is what you get when you cut through a Berkeley current. And I can show you a fist-sized sea pinch as well. So this is a rock I found with a sea pinch on it, and you can see the poles. And rarely you can keep two dragons in one hand. So Earth has sea pinches on top, this rock has sea pinch, so it's scalable, so it would be possible. I'll leave it here. Thanks. Bye.